Hello everyone, I am Dr. P. Rajakumari, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today I would like to explain about some method of grouping and method of multipliers, and I am going to tell some of the problems on method of grouping and method of multipliers. So first of all, how we can solve the given equation by using the method of grouping and by using the method of multipliers. I am going to explain now. So first of all, given equation form, we have to compare with P into P plus Q into Q equal to R. So this is the Lagrange's equation, already we discussed in the previous videos. So this is the Lagrange's equation, that is the form P into P plus Q into Q equal to R. So after that we have to write the auxiliary equation, that is dx by P, dy by Q and dz by R. So this is the auxiliary equation. So after writing the auxiliary equation, so we have to solve these equations to get the solution. What is the general solution? We are going to tell you now. So see here. Here three types of processes are there to solve these type of equations. So first one, if it is possible to separate the variables, then consider any two equations, solve them by integrating, then we can get the solutions. Those are u equal to a and v equal to b. So after getting those solutions, we can write the general solution, that is phi of u comma v equal to 0, phi of u comma v equal to 0, or we can write f of u comma v equal to 0, f of u comma v equal to 0. This is our general solution. So if there is a possibility to separate the variables, we can separate and integrate them to get the solution. This is the type. So in the second type, if it is not possible to separate the variables, what we have to do? So after writing the auxiliary equation, we can solve these type of equations by using the two methods. What are the two methods? Method of grouping, and second one is method of multipliers. So here, what is the method of grouping? What is the method of multipliers? I am going to give the information about these two methods briefly. So you can observe here, after getting the auxiliary equation, that is dx by p equal to dy by q equal to dz by r. So we can take any two equation. That means if you can take 1 equal to 2, that means dx by p equal to dy by q. Otherwise, we can take 2 equal to 3, that is dy by q equal to dz by r. Otherwise, we can take 1 equal to 3, that is dx by p equal to dz by r. So any two equations we can solve to get the solution u comma v. After getting the solution u and v, we can write the general solution, that is f of u comma v equal to 0. This is the method of grouping. So I am going to explain about method of multipliers. So what is the method of multipliers is nothing but we have to check about the condition. What is that condition? I am going to explain you now. Just a minute. So method of multipliers. So here, after writing the auxiliary equation, what is the auxiliary equation? Dx by p equal to dy by q equal to dz by r. So after writing this auxiliary equation, after replacing the p, q and r values, what we have to do is we have to check about the condition. What is that condition? L into p plus m into q plus n into r. E should be 0. Then I can say that L comma M comma N are set of multipliers. Set of multipliers. So here, if I got L into P and plus M into Q plus N into R equal to 0, then I can say that these L and N are multipliers. So here, in this method, we need two set of multipliers to get the equation U and V. So I need to get two solutions, right? So first set, I am going to take L1, comma M1, comma N1. These are the first set of multipliers for the solution U. And I can take the second set of multipliers L2, M2 and N2. This is the solution for V. So after selecting these L1, L1, M1, N1 and L2, M2, N2, I can write the final general solution, that is f of u comma v equal to 0. So here, we are saying that L, M, N are the multipliers. So what are the multipliers we can select? So here I am going to tell you some of the examples about the multipliers. Example, I can take L equal to 1, M equal to 1, N equal to 1. So here I need to select these values. These values are the set of multipliers based on the problem. Otherwise, according to the problem, I can take L equal to M equal to 1, 1, 1. Otherwise, I can take 1 minus 1 minus 1. Otherwise, X, Y, Z. And otherwise 1 by X, 1 by Y, 1 by Z. Or L comma M comma N, R1 by L, R1 by M, R1 by N. Like this, I can select any set of multipliers according to the problem. Those multipliers should satisfy this condition. What is this condition? L into P plus M into Q plus N into R equal to 0. 0. This is the procedure to solve given equation by using the method of multipliers. Now I am going to explain some of the problems based on these methods. Those are method of grouping and method of multipliers. Just a minute. So here, see the problem. Find the general solution of x square into p plus y square into q equal to x plus y into z. So what is the equation here? X square into p plus y square into q. This is the small p dot observe. And here the z equal to x plus y into z. Now I can compare. This is the given equation. This is the given equation. Now I am going to compare this equation with Lagrange's equation, that is capital P into small p, capital Q into small q equal to R. So here capital P equal to, after comparing the equation, what is the capital P? That is x square. What is the capital Q? That is y square. And capital R is x plus y into z. So these are the values of P, Q, R. Now I am going to write the auxiliary equation. The auxiliary equation is, so here dx by capital P is equal to dy by capital Q equal to dz by capital R. So what is the P value? Dx by P is x square equal to dy by Q is y square. Here dz by R is x plus y into z. dz by R is x plus y into z. This is our auxiliary equation. After that, I'm going to do here. I am selecting 1 equal to 2. So what is the 1 equal to? This is I am taking as one equation. This is 2. So I am selecting any two equations here. So that is dx by x square equal to dy by y square. So here when I am taking here, I am selecting any two equations by using the Method of grouping. First, I need to do method of grouping. That means there is a possibility to, by using the method of grouping, I can do. If there is no possibility by using method of grouping, then I will move to multiplier. So here dx by x square equal to dy by y square. Here I can do integration directly because variable separable based on the variable separable method. I am having that all together, that is dx by x square and dy by y square. So I am doing the integration on both sides. 2 dx by x square equal to integral dy by y square. So according to the integration formulas, here integral x power n is x power n plus 1 by n plus 1. X power n plus 1 by n plus 1. So according to that, this is integral x power minus 2 dx equal to integral y power minus 2 dy. So finally this is minus 1 by x equal to minus 1 by y plus c. So finally I can write the equation, that is 1 by x minus 1 by y equal to some constant, that is the solution. First solution, that is u equal to 1 by x by 1 by y. This is the solution. V solution V. So here, so u equal to 1 by x minus 1 by y. This is my first solution. So I need to get one more solution to write the general solution. So I'm going to do now according to the method of grouping. So here I am selecting. So this is the solution you can observe here. Just a minute. So this is the solution just now I explained. So you can observe these steps. So we are getting the solution in this way. So this is the solution only I am getting here. That is u equal to x power minus 1 minus y power minus 1 equal to 7. So now I need solution v. How I can get the solution v? Here you can observe I am doing here dx minus dy. If I do this solution by direct method, I can't get the direct method. If I take any two equations, other 1 equal to 3 also or 2 equal to 3 also, I can't separate the variables according to the condition. So that's why I am doing here grouping. After that, I can get the solution based on this procedure. You can observe here. First, I am doing 1 minus 2, that is dx minus dx minus dy. By same subtraction for the denominators also, x square minus y square, that is equal to, I am equating this one to the third one, that is dz by x plus y into z. X plus y into z. Here I am going to write here derivative of x minus y. I can write this one as dx minus dy. So based on this, I can calculate the value. So that's why I am taking this derivative of d of x comma y by, here I can write x square minus a y square based on the formula a plus b into a minus b. So I can write x plus y into x minus y. Now I can write this is dz by x plus y into z. So x plus y cancel. Finally I got here, I can observe that step d of x minus y by x minus y equal to dz by z. Now I am having the possibility to do the integration. So integral d of x minus y by x minus y equal to integral dz by z. So here integration and derivative will be cancelled. So that is, here I am getting the solution. You can observe. This is in the form of integral f dash of x by f of x dx. So f dash of x by f of x dx is nothing but log f of x. That is log f of x. According to this formula, I can write log of x minus y equal to 1 by z is log z. Here I am having these two values in logarithms. That's why I'm adding constant with the logarithm. So log C2. So already I used C1 for the first solution. So I'm using here C2. So according to the logarithmic formulas, I can change these values. Log of x minus y minus log z equal to log C2. So now log a minus b. I can write log a by b. So x minus y by z is equal to log C2. So now this is equal to x minus y by z equal to C2. This is my second solution, that is v. So this is nothing but here we can see. So I got u is x power minus 1 minus y power minus 1 and v is this one. So this is equal to c1. So finally a general solution is f of u comma v equal to 0. That is f of u is x power minus 1 minus y power minus 1 comma x minus y by z. Otherwise I can write z inverse also. This is our general solution. So this is our final solution after doing the procedure by using the grouping method. Now see this. Solve px plus qy equal to x. Here I am going to do the solution now. Given px plus qy equal to x. Here I am comparing with Lagrange's equation, that is capital P to small p plus capital Q into small q equal to r. So now I am writing capital P equal to x, capital Q equal to y, capital R equal to x. So now I am going to replace these values after writing the auxiliary equation. The auxiliary equation is dx by p equal to dy by q equal to dz by r. So now I can write these values here. Dx by x equal to dy by y equal to dz by x. Now I am using the method of grouping. So according to this, first I am selecting 1 equal to 2. So 1 equal to 2 means I can take dx by x equal to dy by y. So here there is a possibility to do the direct integration. So integral dx by x equal to integral dy by y. So this is nothing but here I got log x equal to log y plus log c1. So finally I can write this is log x minus log y equal to log c1. So based on this I can write log x by y equal to log c1. So finally x by y equal to c1. This is my first solution. What is my first solution? U equal to, I got here x by y. U equal to x by y, that is equal to c1. So I need to get v now. So now I taken here 1 equal to 2, right? So now I am taking 1 equal to 3. So here dx by x equal to dz by x. Now x will be cancelled. Otherwise you can do the cross multiplication. Then you can cancel the x according to your knowledge. So according to your flexibility, you can do here x into dx equal to x into dz. So here x will be cancelled. So finally I got dx equal to dz. So now I can integrate. So integral dx equal to integral dz. Nothing but this is x equal to z plus 2. So here v I got here. Based on this x minus z equal to c2. My solution is here x minus z. Now I can write the general solution. So general solution is f of u comma v equal to 0. So f of x by y comma x minus z equal to 0. This is my final general solution. This is the way to solve the given problem by using the grouping method. See the next problem, that is find the general solution of partial differential equation, that is y square. Y square u into p plus x square u into q equal to y square x. This is the given equation. So now I am comparing with auxiliary Lagrange's equation, that is p into p plus q into q equal to r. Now my p is y square u and my q is, sorry, here capital Q. So capital Q is x square u and capital R is y square x. Now I'm going to replace here in the auxiliary equation. You can observe auxiliary equation I'm writing. So dx by p is y square u, dy by q, that is x square u. Next here we are having the variable, that is z. Variable is z. So that's why here in place of z we are taking du by xy square, because we are having the variable is u. So according to that we have to take, if z is there we can take z, if u is there we have to take u. So here we are having the variables x, y, u. So now I am going to solve the equation dx by y square u equal to dy by x square u equal to du by xy square. Now I am going to use the method of grouping. So based on that, first I am taking here first two numbers. What is the first two numbers? To dx by y square u equal to dy by x square u. Here u is common. I am cancelling this and doing the cross multiplication here. So then x square dx equal to y square dy. Otherwise, before cancelling the u also, you can do the cross multiplication here. You can observe that one also. Based on your flexibility, you can simplify the equation. So many simplification ways are there. According to that, you can simplify. So here, if I am writing u into x square dx equal to u into y square dy. So u is cancelled. Here I can do the integration directly. So x square dx equal to integral y square dy. So here x square dx is nothing but x cube by 3 equal to here y cube by 3 plus some constant. So based on this, I can write this one as x cube by 3 minus y cube by 3 equal to some constant. I'm taking here x cube minus y cube equal to this 3 I'm sending here 3 7 I can write total constant. So finally my solution is u equal to x cube minus y cube equal to 7. This is my first solution when I am taking the 1 and 2. So u equal to I got here x cube minus y cube equal to 7. This is my first solution. This is my first solution. So this is only they got here. Next I am taking, so here you can observe. Next I am taking first one and third one. What I am taking here? First one and third. So here 1 equal to 3. First one and third one I am taking. What is the first one? Dx by y square u equal to du by x y square. So here I am going to do the cross multiplication again. Then I got here so x y square into du equal to y square into u d. X y square into dx equal to y square u into du. So y square is cancelled here. So finally I got x dx equal to u du. So now I am going to do the integration. Integral x dx equal to integral u into du. So here this is x square by 2 equal to u square by 2 plus C2. Finally, I am writing here x square by 2 minus u square by 2 equal to C2. So, I am going to simplify this. X square minus u square equal to 2C2. I can write total constant as C2. If I multiply with some constant, I will get the same constant only. So here I got the V solution, that is x square minus u square equal to C2. So now I got the u and v. So finally I can write f of u comma v equal to 0, that is f of x cube minus y cube comma x square minus u square equal to 0. So this is our final solution what we observed here. So this is the way to solve by using the method of grouping. Next, here we are going to solve one more problem based on this. Solve x square minus y square minus z square into p plus 2xy into q equal to 2xz. X square minus y square minus z square into p equal to 2xy cube equal to 2xz. So now I am going to solve this one. Given equation is x square minus y square minus z square into p plus 2xy into q equal to 2xz. Now I am comparing with the Lagrange's equation. So comparing with capital P into small p plus capital Q into small q equal to R. So now I am writing P values. P equal to x square minus y square minus z square. Q equal to 2xy and R equal to 2xz. Now I am going to write the auxiliary equation. The auxiliary equation is auxiliary equations. So dx by capital P equal to dy by capital Q equal to dz by capital R. Now, so I am substituting here dx by x square minus y square minus z square equal to dy by 2xy equal to dz by 2xz. Now, here I can choose method of grouping according to the given equations, and after that I will check about the multipliers method. So first I can choose 2 equal to 3 by using method of grouping to get the solution. So I am taking here 2 equal to 3. So 2 equal to 3 means I am taking this one as first one, second member and third member. So second member and third member I am selecting here. dy by 2xy equal to dz by 2xz. So here I am doing the cross multiplication, that is 2xz into dy equal to 2xy into dz. So here 2 will be cancelled and x will be cancelled. Now I am separating the variables here. dy by y equal to dz by z. I got here dy by y equal dz by z. Now I can do the direct integration. Integral dy by y equal to integral dz by z. Now this is 1 by y, that is log y equal to log z. Plus here I am having both logs, that's why I am adding constant also with the logarithmic. So log y equal to log z plus log 7. So log a minus log b I am going to write here. Log a, that is log y minus log z equal to log 7. So finally this is log y by z equal to log 7. So finally after Cancelling this, I am getting the solution y by z equal to c1. So finally u equal to y by z, that is equal to c1. So this is my first solution. After that, how I can get the v? How I can get the v? So if I take 1 equal to 2 also, there is no possibility to get the solution. If I take 1 equal to 3 also, I don't have the possibility to get the solution. That's why I am doing here. I am going to take some of the multipliers to solve this to get the second solution. So here I am writing, I am using the auxiliary equation again. So this is just a minute. You can observe here. So here this is dx by x square minus y square minus z square equal to dy by 2xy equal to dz by 2xz. Now I am going to write this one as a multipliers of the sum. I am multiplying first one. I'm going to multiply first one with the x and second one with the y and third one with the z. That will be here you can observe first x into dx plus y into dy plus z into dz. Now here, so x into dx. So numerator is this. The same way you have to multiply with x for the denominator also. So x into x square minus y square minus z square plus y into dy numerator. So same y into dy for the denominator also, that is 2x, y into y is y square plus z into dz for the third one, that is numerator z into z. So denominator is 2x 2x z square. This is only we got after simplifying this. So here I am writing x dx plus y dy plus z dz by, here multiplying with x, this is x cube minus xy square minus xz square plus 2xy square plus 2xz square. Finally, I got here x dx plus y dy plus z dz by, here x cube. So here 2xy square plus 2xy square minus 2xy square is there. I can write this is plus xy square plus here plus 2xz square minus xz square. I got here xz square. So finally I am getting the solution here. This is x dx plus y dy plus z dz by, here I am taking the x common. So x square plus y square plus z square. So this is only value we got here. I am going to equate this one as a fourth member. So that is x dx plus y dy plus z dz. What I am doing here, I am using the multipliers x, y, z and I am equating this one to the auxiliary equation. Then only I can solve this to get the second solution. So here I am using multipliers also and grouping together. So this is, I got x into x square plus y square plus z square. Now I am going to take any two equations here to get the solution. What is that I can take here? Now I am considering third one and fourth one. This is the first member, this is the second member, this is the third member, and this is the fourth member. Now I am taking third one and fourth one. Third one equal to fourth one. Now dz by 2xz equal to x into dx plus y into dy plus z into dz by x into x square plus y square plus z square. Now x will be cancelled. X will be cancelled. Now I am writing this one. I am separating the variables here. dz by z equal to, I am going to send this to here this side. Then 2x dx plus 2y dy plus 2z dz by x square plus y square plus z square. Now we got the information why I done this type of simplification means I am going to get here x square derivative is 2x dx, y square derivative is 2y dy, z square derivative is 2z dz. Now I can write. So after doing this simplification, I got the value like this. So now I am going to do the integration to get the second solution. Yes. So here some of the problems we can do, we can by using the method of grouping to get the two solutions. Some of the problems we can do by using the method of multipliers to get the solution. But some of the problems one solution can get from the multipliers, one solution can get from the grouping. And sometimes mixed like this, first we have to take the multipliers and after we have to do the grouping. So this type of problems also is there. So according to the problem we have to solve. Here I got 2x dx plus 2y dy plus 2z dz. Here plus z. So divided by. So that means here I got x square plus y square plus z square. Here now I can do the direct integration. So because x square derivative is 2x dx, y square derivative is 2y dy, z square derivative is 2z dz. So now I am doing integral dz by z equal to, you can do the integration here, integral 2x dx plus 2y dy plus 2z dz by x square plus y square plus z square. Now I can write this 1 by z is log z. So log z equal to, here we are having the form that is integral f dash of x by f of x form. So that means I can write this one as a log f of x, log f of x. So I can write here log x square plus y square plus z square. So here I got 2 in terms of logarithmic only. So that's why I'm adding log c2. So now I'm sending here to LHS part log z minus log x square plus y square plus z square equal to log c2. So now log z by x square plus y square plus z square equal to log c2. So finally, after cancelling the logarithmic, I got z by x square plus y square plus z square equal to c2. This is my solution B. So after that, I can write the general solution. So general solution equal to f of u comma b equal to 0. Replace u here, replace v here. U I got y by z. So f of y by z comma here z by x square plus y square plus z square equal to 0. This is a general solution. This is our general solution. This is the way to solve the problems by using method of grouping and method of. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.